So I want to review quiz 3 in this session. All right, let's go through the questions. Which of the following statements are true about the eras of digital computing? The World Wide Web was invented in the enterprise computing era. Yes, that is indeed true. It was invented in the enterprise computing era. Grid computing defines one of the eras in digital computing. That is not true. Grid computing is, you may call it an emerging technology, but it's not defining an era of computing. So that's why 2 is not true. 3, local area networks did not exist in the mainframe era. That is correct. They were invented, local area networks were invented in the client server era. So mainframes to PCs to client server. It's in the client server era when local area networks were invented. So that's why 3 is true. Distributed processing characterized the mainframe era. That is not true. The mainframe era is referred to as centralized processing. So that was the era of centralized processing. All the processing occurred in the mainframe. We didn't have PCs, so you couldn't have distributed processing where some of the processing occurs in the mainframe or the server and some of it occurs in the client machine. PCs were not there in the mainframe era. That's why 4 is not true. There was no distributed processing in the mainframe era because PCs had not been invented till quite some time later. So here, essentially 1 and 3 are true. One important benefit was offloading of the client server era was offloading files from the PC to a file server. Yeah, this is very much true. The client server era was, ran from the 90s, from the 80s. And at that time, storage space in a PC was quite limited, was very limited. You would get a PC with let's say 30 megabits or 50 megabits or so storage. Compare that to the storage that we get today in a laptop or a PC. You can easily get terabytes of storage, 1 terabyte or more, even in a low end or in a low end device. So that's a lot of space compared to what we had during the client server era in the 1980s. And that's why this was a major benefit that you could offload the files. Instead of keeping the files on your PC, you could essentially keep them on the file server. And that didn't chew up the disk space on your PC. So that is why this offloading of the files to the file server is a key benefit. That makes that statement true. Which of the following statements are true about the IT market landscape? So this is about, you got to know some of the players. That's useful information. That's part of your IS literacy to understand the IT market landscape. So IBM acquired Lenovo's PC business. This is false because it was the exact opposite of this that happened. Lenovo acquired IBM's PC business. Cisco is well known for making software for integrating different business applications. No. Cisco is a well-known networking vendor. So they're well known for making routers, switches, network interface cards. It's a networking vendor. So both 1 and 2 are not true. MySQL is an open source operating system product. This is not true. MySQL is an open source product, but it's an open source database product, not an operating system product. So that's why 3 is also not true. Cisco and Oracle are close competitors. No, Cisco is in the networking space. They make routers, switches. Oracle is known for its database products and also its software application products. So you can buy an ERP system from Oracle. You can also buy a database from Oracle. So it's known for its databases and its application software offerings. So that's why none of these statements are true. Which of the following goals primarily fit within green computing? Reducing power consumption in data centers. Yeah, that absolutely fits within green computing, because electricity has to be generated from someplace. Often it's generated from a thermal power plant, which is burning coal, and it's basically generating a lot of greenhouse gases, generating carbon dioxide. So, and that's not green. That's completely antithetical to the green movement. So, what we are looking for are ways of reducing power consumption in data centers, so that we have to, generate less electricity. So reducing power consumption is true, and so consolidating the servers in the data center through technologies such as virtualization, server virtualization, that's helpful, because that reduces the power consumption, it reduces the number of servers, it's reducing power consumption, and therefore it's helping the green movement. So that's part of green computing. So reducing power consumption, which is number one option, that is true. Having computer vendors make self-healing computers. In other words, make autonomic computers. No, that's not directly within green computing. So that falls outside of green computing. Consolidating the servers in data centers, the third option. This falls within green computing, because now you're having to generate less electricity. Providing equal access to all internet content providers, no, this doesn't have much to do with green computing. This is about what kind of information you can place on your website. And equal access means that, well, everybody is allowed to place their content, and we won't censor that content. Subject to some extreme conditions, of course, but by and large, internet equal access means that we're not censoring the content that people like to place on their websites. So here, only 1 and 3 are things that support green computing. Service-oriented architecture. Using the service-oriented architecture saves costs by reusing software components. That's exactly true. That's what the service-oriented architecture is all about. It's about reusing previously built software components. So if some software components have been built by other software teams prior to your starting your software development for whatever purpose that software development is intended. So the new software development should look at what has been done previously and what components have been made available by previous software teams, and reuse that rather than reinvent the wheel yourself. Before this before service-oriented architecture, where software is built in modules or components, and those components provide their services to other software components that are being built later on. So this is what is reducing, reinventing the wheel, and therefore reducing software development costs. So that's why it does save costs by reusing software components. SaaS refers to the notion of outsourcing the building of software to countries where programmers are expensive. No, that's outsourcing. Delivering security as a service. No, it's delivering not necessarily security, it's delivering software applications as a service. So if you want an ERP system, instead of installing the ERP system on your own data center, where you'd have to buy your servers and also buy the software, instead of doing that, just use the ERP system at the cloud computing provider's data center. So on a monthly subscription basis or number of users basis, you would simply be renting the ERP services from a cloud computing provider. And that's what SaaS is. So SaaS stands for Software as a Service. So it's really about renting application services from a cloud computing provider. So that's why that is the correct answer. The technology that allows more computing power to be packed into the chassis of a computer. So this is blade computing. So you get you get more compute power through two ways. One is you make the CPU chip more powerful, which means you are able to pack in a lot of electronic circuitry on that CPU chip. So that's one approach, and that's Moore's law of computing. The other way you get more computing power is through this notion of blade computing, where where each blade is a self-contained computer. And as you pack more of these blades into the chassis of the overall computer, then the compute power in that chassis is increased. So that's one of the ways that compute power is increased, through blade computing. Which of the following statements are true about cloud computing? Security and reliability issues with cloud computing have become less of a problem today. Yes, this is correct. This was a problem in the early days of cloud computing, but cloud computing has been there for quite some time. It's been taking off more recently, but it has been there for quite some time. And so that's why today's era is known as the era of cloud and mobile computing. So these issues were there at the early stages. You go back 12 years or so, 12, 15 years, then yes, cloud computing was not that mature, and these issues of security and reliability were there. But if you look at it today, these issues have been largely settled in many cases, most cases. Large companies do not use cloud computing. That's not true. Large companies have a hybrid environment where they have their own private data center, but they're also renting some services from cloud computing providers. So therefore, that statement is not true. They do use cloud computing. Cloud computing can make use of the same type of technologies in a firm's data center. For example, SaaS. Yes, absolutely. So the cloud computing provider's data center can have the same set of technologies: social storage area networking, SaaS, server virtualization, hypervisors, you name it. The whole gamut of technologies that can be used in a private data center can also be used in the cloud computing provider's data center. So that's why 3 is true. Cloud computing triggered the era of grid computing. As I mentioned earlier, there was no era of grid computing. Grid computing is an emerging technology. Actually, grid computing was almost dying because there were not too many applications for it. Now, grid computing is being revived by the whole digital currency thing. So Bitcoin, the blockchain for Bitcoin, actually runs on a grid computer. So grid computing is making a certain revival. So here, what do we see here? 1 is true, 2 is not, and 3 is true, and 4 is not. One important benefit of the client-server era was to split the processing between the client and the server to increase performance. Yes, that's true. This was one of the benefits. In fact, the product that I used to manage, called NetView, the purpose of that was NetView would go out and, it was an IT product, it would go out and discover the entire network to find what PCs, what servers, what routers, what switches you had on your network. And before, the NetView was such that you could only run it on a server, but we actually split NetView into a 2-tier application where a portion would run on the client, portion would run on the server. So in that sense, why we did that is because we wanted to boost the performance of NetView. So essentially, we went to a distributed processing model, and that increases the performance of NetView. So I saw this directly happen. So indeed, splitting the software up into 2 layers, a client and a server, will improve performance. In order to run a software application on a computer, the computer must have an operating system. So it must have an operating system. Okay. After the breakup of HP and IBM Enterprise are close competitors. Yeah, this is true. So what happened with HP is that HP broke up into two separate companies. One is called HP Inc. and the other is HP Enterprise. So HP Inc. has their PC business and also their printer business. So that is an HP Inc. HP Enterprise has all their servers, the server business, the large computers, and other software that HP also offers. So it has the enterprise business, and because it has the larger computers, and the PCs are being put into HP Inc. So IBM is not competing directly with HP Inc. because IBM does not have a PC business anymore. IBM sold its PC business to Lenovo. What IBM is competing with is with HP Enterprise after the split of HP. So yes, in that sense, IBM and HP Enterprise are close competitors. When storages are pooled, computer servers access these storage disks via a storage area network, a SAN. In addition to offering various types of IT products, IBM is also a key vendor of database products, and that's true. IBM is a vendor of database products as well. So the main IBM database product is IBM DB2. So that's its database product, IBM DB2. Which of the following statements are true about SANs? SANs decrease the cost of storage, yes, because they consolidate the storage disks. They consolidate the storage disks. There isn't the inefficiency, the waste that we find when the storage disks are directly attached to the servers. In that model, also known as the direct attached storage model, one server storage disk might be 100% utilized, while the other server storage disk is 20% utilized. But the server that has run out of its storage disk cannot use the unused storage disk in other servers in the direct attached storage model. This is the problem that storage area networks remove. That's the problem that this network removes, storage area network, by having the disks be a common pool of storage for all servers. So in that sense, they reduce the cost of storage. A SAN is a back-end network, while Ethernet is a front-end network. Yes, by definition. That's the definition of the term back-end and the term front-end. SANs are the purpose of directly attaching storage to servers? No, that is the direct attached storage model. And there was waste and inefficiency in that model, where some servers had storage that was very lightly utilized. So that was an inefficiency. And that's why we invented SANs, so that you don't have to directly attach storage and you can keep it in a common pool of storage. So that's why 3 is not true. 4, cloud computing providers cannot benefit from the technology of SANs. This is not true. Anything that is in the that a private data center operator can use, technologies such as virtualization and storage area networking, these can be used by the cloud computing provider as well in their own data center. So that's why here only 1 and 2 are true. Client-server computing is a form of distributed processing. Yes, it's just that's what distributed processing is. You can have one piece of the software running on the client, another piece of the software running on the server. Which of the following statements about Linux are true? Linux is now owned by IBM. No, Linux is open source software, so it's not owned by anybody. Linux is spreading quickly and is now moving into mobile devices such as smartphones. Yes, this is true. There are a number of smartphone operating systems that are actually based on Linux. So that's that. We are seeing that movement happening. Linux has 80% of the server operating system market. No, that's not true. Microsoft Windows has about, not as high as 80%, but somewhere in the around the 75% range. So Microsoft has that. Microsoft Windows has that. Linux is freely available, it's downloadable from the internet. Yes, it's an open source product. So here we see 2 and 4 are true. Cloud computing is supportive of green computing, yes. Because what we're doing in cloud computing is we're getting rid of all the individual data centers. So we're getting rid of all the the power consumption that happened when firms had their own data centers. Now we're renting the services from the cloud computing provider's data center. So admittedly, the cloud computing provider's data center has to have a significant number of servers, and so you have to send electricity to the cloud computing provider's data center. But the electricity consumed by the cloud computing provider's data center is actually smaller than the electricity consumed by all the data centers that we would need to have implemented if we kept our own private data centers. So, there's electricity being consumed by the private data centers, and the sum total of that is actually greater than the electricity consumed by the cloud computing provider's data center. So in other words, from an aggregate point of view, cloud computing is indeed reducing the aggregate electricity consumption. And that's why cloud computing is supportive of green computing. ERP software is responsible for managing the functions by the computer. This is false because it's the operating system software that is responsible for managing the functions provided by the computer. Which of the following statements about cloud computing are true? Cloud computing generally lowers the cost of delivering application services. Yes, that is true. That's why the small and medium businesses have all essentially gone to cloud computing, because now they're getting application services cheaper than if they had implemented their own data centers with their own servers, their own software, and of course, IT staff is needed as well. And IT staff is an expensive, component of the whole IT costs. So yes, cloud computing generally lowers the cost of delivering application services. This is why the SMB, the small and medium businesses, find this to be a very attractive model. Cloud computing providers deliver software as a service. Yeah, that's what cloud computing providers do. It's SaaS, the SaaS model. That's what cloud computing providers implement, software as a service. The long-term business model of cloud computing, whether it'll be cheaper over a 20-year period, is yet to be proven. That is correct. That is correct. So, so we don't know if renting these application services from a cloud computing provider, if you add up the monthly or yearly costs and project it out, over a 20-year horizon, would that total cost that you would have paid to cloud computing providers, would that be less or more than if you had retained your own private data center? So that's that is still a question that is under research, if you will. Nobody's really actually built a good model for accumulating the costs over a long period. We also have to take into consideration things like the the discount rate, because we would have to find the net present value of the costs incurred later in that 20-year time horizon. A serious analysis of this has really not been done. So this is still somewhat of an open question out in the industry. But the main thing is, who cares about what happens 20 years from now? A lot of companies, particularly in the US, have a much shorter time horizon for strategic planning. So nobody's really looking out 20 years from today. So cloud computing, certainly in the short term and the medium term framework, is certainly cost reducing. And so since companies do strategic planning, not further out than, let's say, 3 to 5 years, that's why it's not a huge concern about whether this model would turn out to be cheaper if we project it over a 20-year horizon, because nobody's doing strategic planning over 20 years. So that's why this question has really not been, analyzed in great depth right now. SaaS and virtualization can be used in both the cloud computing provider's data center. Yes, it can be. So that's what I said, which is that whatever technologies you're using in your private data center, you can certainly use in the cloud computing provider's data center. So really 1, 2, 3, 4 are all true. SAN refers to the notion of lowering the cost of building software applications by reusing pre-built components. No, it's SOA. So we're using the wrong acronym, which is why this statement is false. So that is SOA, service-oriented architecture, which is about the cost of lowering software by reusing pre-built components. Which of the following statements is not an example of application software? So SCM, ERP, CRM are all application software. Linux is an operating system. So that's why it's not an example of SCM software. Which of the following statements are true about the different eras of digital computing? Distributed processing was invented in the PC era. No, it was invented in the client-server era, which followed the PC era. So that's why that is not true. Storing files on a file server on your PC is a form of client-server computing. Yes, that is true. That's why the two main benefits were distributed processing of the client-server era, were distributed processing for boosting application performance, and the other main benefit of the client-server era is that you could offload the files from your PC, where you had limited disk space, onto a file server, onto a proper computer with a significant amount of disk space. So that's why 2 is true. Key application of the wide area network enterprise is the World Wide Web. Yes, that was part of the enterprise era. And that's when enterprise networks essentially came into being. And one of the applications of enterprise networks was the World Wide Web. The most famous application of the enterprise computing era was the World Wide Web. Local area networks were used to connect PCs to servers in the PC era. No, we just said that there were no local area networks yet in the PC era. So that's why here only 2 and 3 are true. Which of the following statements are true about IT infrastructure and emerging technologies? Blade computing results in a doubling of the computing power every 18 months. No, that's Moore's law of computing, not blade computing. Mobile computing is part of the current era of digital computing. Yes, the current era is known as cloud and mobile computing. So 2 is true. Aligning the technology with the business model is expected to remain a challenge going forward. Yes, no matter what technology comes down the pike, this is always going to be a challenge, if you will, a perennial challenge. This is a challenge that really isn't going to go away. So in some cases, even more complex technology might actually make this challenge even worse. But this is the challenge about how we align IT with the business. And ever since the dawn of computing, this challenge has been there. And we don't see that going away. Businesses are moving to the grid computing model. No, they're not. Grid computing never really took off in businesses. Now it's trying to make a comeback through Bitcoin. But again, that's not, that's not businesses moving to a grid computing model. That's simply that the Bitcoin blockchain network is being implemented on a grid computing architecture. Okay, so then what we see here are 2 and 3 are true. Invoking a web service involves an exchange of HTML documents between the calling application and the web service. It involves an exchange of XML documents, XML, not HTML. Which of the following statements are true about trends in the IT infrastructure? Autonomic computing is widely deployed in businesses? No. Autonomic computing is It's kind of still somewhat in the research phase, but it's an application of AI, which is having self-healing computers, and AI is still AI is a collection of technologies, and some of them are well developed, while others are being further developed before we really see the fruits of that. So autonomic computing is an application of AI, but it is still an evolving technology. So it's not a widely deployed technology as yet. The search for extraterrestrial, the SETI, yeah, that's an example of an application running on a grid computer. Mobile computing is part of the enterprise computing era? No, it's part of the current era, which is cloud and mobile computing. The enterprise computing era preceded the current era of cloud and mobile computing. Server virtualization helps in consolidating the number of servers. Yes, it does that. It does help in consolidating the number of servers. Because now a server with the so-called hypervisor layer installed there can support applications written to different operating systems. So you can have a Unix application and a Windows application run on that on this server with the hypervisor virtualization layer. What this does is it reduces inefficiency in the use of the server's computing power. And I think I gave an example during in the lecture. Supposing you had a computer server that was very highly utilized. Maybe there was some a BI application for Unix that was very popular. A lot of people wanted to use that BI application, and it's running on this Unix computer. So your server A is basically a Unix computer, and the rest of the servers in your data center are Windows servers. Well, you could not move, and let's assume that those Windows servers were not entirely utilized. They were lightly utilized. They were not heavily utilized. So what we have is we have spare cycles in the Windows servers, but we can't move this Unix application to a Windows server. Unix is not going to run on Windows if you've installed the Windows operating system on that server. So what virtualization does is actually it allows us to move the Windows application to that other server, which was a Windows server. So we'll have to deinstall Windows and install the hypervisor layer on that other server, which used to be a purely dedicated Windows server. Now, as we have installed the hypervisor layer, the virtualization layer, now we can run both Unix and whatever were the original Windows applications running on that lightly utilized Windows server. So this means that we don't have to go out and buy another Unix box. Now we're moving some of the users from that heavily utilized Unix system and moving them to other servers which were lightly utilized. And these other lightly utilized servers which were running Windows can now run both Windows and Unix. That's the beauty of the virtualization technology. And in doing so, we are basically ensuring that all of our servers are heavily utilized. We want them to be heavily utilized to the extent of at least 80% or more, even like 90%. Otherwise, we're just wasting our server compute power. We don't want that. We want the servers to be heavily utilized. That way, we will have less servers. We can consolidate the servers. If we had a few servers that were heavily utilized, then one or two servers that were completely out of compute capacity because they're so heavily utilized, and we have other servers which are lightly utilized. That's an inefficient picture. That's an inefficient architecture. So that's where server virtualization comes in, and it allows all the servers to be reasonably heavily utilized, so that we are using this server compute power efficiently. So therefore, it indeed helps in consolidating the number of servers, so virtualization. So here what we see is 2 and 4 are true. Which of the following statements about Unix is not true? Unix is not open source software. That's what is not true. So Unix is not open source software, but all the other statements are true. It is a competitor to Windows. It is a type of operating system, and IBM does have a Unix variant that they offer. Which of the following statements are true about the IT market landscape? Profit margins are much thinner in the enterprise computing space than in the PC space. No, it's exactly the opposite. Profit margins are much thinner in the PC space than in the enterprise computing space. And that's why you see a lot of the Asian manufacturers in the PC space, Huawei to Samsung, Acer. So a lot of Korean and Chinese manufacturers are in there because they can compete better. They have a low-cost structure, so they can compete better. And U.S. companies, well, we have a higher cost structure, and so it's difficult for us to make money in the PC space. And that's why IBM was early to see this. And that's why they sold off their PC business to Lenovo, the Chinese company, because IBM was finding it difficult to make money on that. Okay, next is if you want to buy network equipment, Cisco would be a good choice, indeed. Cisco is the most famous networking equipment vendor. Microsoft produces a version of the Unix operating system. No, Microsoft is all about Windows. Dell has acquired EMC. This is correct too. Part of how the IT market landscape is shifting. So what we see here is 2 and 4 are true. Assume your firm wants to buy storage systems and has received a bid from EMC. So I had said that if you want to bring any IT vendor down on price, be it on servers or storage or software, you should bring a bid from a competing vendor, which is more attractive. And that's when the vendor you're talking with will reduce their price. So if you're trying to buy storage, should you bring a competing bid from Cisco? No, Cisco is not a storage vendor. It's essentially a networking vendor. So you would not try to get a bid from Cisco. You would try to get a bid from other storage vendors, such as Western Digital, Seagate. There are a number of other storage vendors to choose from. EMC, Seagate, and Western Digital are the primary ones. So that's why that statement is false. The government cannot take advantage of cloud computing technology. No, it certainly can. It certainly can. It may not want to move its sensitive applications to cloud computing. Like, the government has a secure mail system, so that you may not want to move to cloud computing. But not all mail is secure. I mean, not all mail is highly sensitive that goes around in government organizations. A lot of the mail is mundane mail, such as, hey, where's the next, which conference room is the next meeting in? So the non-sensitive email, those things can be moved to a cloud computing provider's data center, and that would lower the costs. Because the primary benefit of cloud computing really is lowering of the cost. Okay, so this brings us to the last question, which is on hyperconvergence. So the notion of hyperconvergence is to actually do away with the physical storage area network and replace it with a virtual storage area network. So hyperconvergence is about virtualizing storage. So that first option, hyperconvergence virtualizes the SAN, that is true. In hyperconvergence, you don't have any SAN switches. You don't have external storage disks attached to the SAN. What we do in hyperconvergence is we're using the internal disk, the internal storage of the various servers or host computers, and bringing those internal disks into a virtual SAN, if you will. So the physical SAN is no longer there. These internal disks are brought into a common pool of storage. So the internal disks together comprise a virtual SAN. So that's what makes that first statement true. Hyperconvergence can reduce IT costs by eliminating the SAN and its associated costs. Yes, that's very true. Because we are eliminating, see, if you implement a SAN, you need some kind of a SAN switch as well, which is the backend network. So you're eliminating the backend network. You're eliminating the SAN switch. You're eliminating the external storage disks that were attached to the SAN. Now you're simply using the internal storage. So, and making that into a common pool of storage. Now, one of the reasons why we can now do that is because that internal storage could be solid state storage, solid state device, SSD storage, meaning flash memory. So flash memory has become cheap, it's become plentiful. So you could actually put in a lot of flash memory into a server. And then if you collect the flash memory of multiple servers into a virtual, a virtual pool of storage, then that essentially becomes your storage area network. You don't have to implement an external storage area network. The internal disks together can become like a common pool of storage. So yes, then you're eliminating the costs of the SAN switch and all that external storage. So 2 is true as well. 3, the problem with the SAN model is when you move a VM from one hypervisor host to another, you have to move all the files associated with that VM to the other host. This is not true. This is not true at all. In the SAN model, the operating system and the applications that run in a given virtual machine are installed on the external disks that are attached to the SAN. The external disks are available as a common pool of storage that any of the host computers or servers can access. So therefore, when you move a virtual machine from one physical host or server to another physical host or server, the files don't have to move. The files are in the common pool of storage attached to the storage area network. So here we're talking about a physical storage area network. The files are attached. The files are on the disks attached to the storage area network. So those files are available by any of the host computers or servers. So they don't have to move when you move the virtual machine from one host computer or server to another. So third is not true. Third is trying to say you have to move the files. No, you don't have to move the files. The files can be accessed by any host computer or server. So third is not true. Fourth, the problem with hyperconvergence is that if the host where the files of VM reside go down, that VM can no longer function. Now, this is not true because in the hyperconvergence environment where we have a virtual SAN, and the virtual SAN is actually, the storage is actually coming from the internal disks in the host computers or servers, the data is kept redundantly. So it is not that the data, the files are kept in just a virtual machine's files are kept in just one host computer. No, the data, there are many host computers whose disk has been collected and made into a common pool of storage. And so the data is kept redundantly. It's not resident on just one host computer. So if that host computer or server goes down, well, then the virtual machine, which is tied to that set of files, can no longer function. No, the virtual machine's files are actually replicated and kept in several different locations. So it could be kept in 2 or 3 different host computers. They're replicated. So therefore, if one host computer goes down, which has one replica of the files needed by a certain virtual machine, if that goes down, it doesn't affect the functioning of the virtual machine. The virtual machine can then simply switch to the second replica, which is there somewhere in this set of hosts whose internal storage has been virtualized and made into a common pool. So that's why 4 is not true either. So that's why the only true statements here are 1 and 2.